Our last video for rate and kinetics is about catalysts. So you have used catalysts in lab before and you have probably heard about them, but just for a definition, a catalyst is a substance that increases the rate of reaction, but is not consumed by the reaction. So whatever this catalyst is doing when it's inside the reaction, it is exactly the same at the end of the reaction, so it can go back and assist with getting the reaction to go more quickly again. So this is why, because it's not consumed in the reaction, occasionally you will see in procedures for experiments to use a catalytic amount of something. This just means small, because whatever you put in, it will be able to go through many, many cycles of the reaction because you're not going to use it up. And so it's not going to appear in the balanced reaction typically because it's not a reactant or a product. It's just there to assist to make sure that it goes quickly. So you can have two different types of catalysts. You can have a homogeneous catalyst that is in the same phase as the reaction. So this would be if the reaction is happening in solution, the catalyst is also soluble. And so it's dissolved in whatever the solvent is and helping the reaction go that way. Or you could have a heterogeneous catalyst. And this just means that it's in a different phase. So if your reaction is happening in solution, your catalyst is something like an insoluble solid. So it's some type of surface maybe that the reactants go to and the catalyst helps them react more quickly. So the way that this works, catalysts work by lowering the activation energy of a reaction. So let's draw a picture for this to show what we mean. So of course, we're going to draw an energy diagram. So the energy as the reaction goes, and I'm just going to put a sample curve on here because we're going to end up making it exothermic. Doesn't matter. You could have catalyzed reactions that are endothermic. So this is the uncatalyzed path. And whatever difference happens, it depends on the actual reaction. It depends on the catalyst you use. All it does is get this reaction to go by a path that has a lower activation energy, right? So my uncatalyzed, right, had this activation energy, and then my catalyzed has this much lower value for activation energy. I want to draw a second catalyzed path on here. So this is where I just have one energy barrier to get over still. Depending on, like I said, the identity of the things in the reaction, the identity of the catalyst, your catalyzed path may actually end up being a couple of steps. So you might get something like this. Call this alternate catalyzed path. And you can see the important part is that it still has lowered the activation energy relative to what it was originally. So this is all we have for catalysts. It's just explaining what they are and how they work. And this is something that you will see constantly as you go through a pre-medical curriculum of any kind, because enzymes are catalysts that work on biological pathways.